Good morning, students. In the previous video, we have discussed about chapter friction. We have started the friction chapter and we have discussed about the definition as well as properties and the factors upon which friction depends. Now, let us move further. Let me take you to the types of friction. Let me share my screen with you. Now, the types of friction. There are three types of frictions, that is static, sliding, and rolling. Let us understand. Here you can see this car is standing on the ground and person is pushing it, but it is not moving. So static friction is the frictional force that exists between two bodies so long as they are relatively at rest, even though an external force is acting upon them. If the object is not moving, either the external force is also applying upon that, but the objects are at rest. So this kind of friction, which is opposing the movement of this object, is called static friction. Then how we can like overcome this friction? It is because it is the opposing force that comes into play when one body tends to move over the surface of another, but actual movement has not started. This static friction is actually opposing the movement of this car. Although we are applying the force, although the body tends to move over the surface of another, but actual movement has not started yet. So this is having this, here the static friction is exerted. Then what happens? This static friction must be overcome before an object can be set in motion. We have to push harder. We have to just give a kick to this car or give a push to this car harder. So we have to overcome the static friction. Then only this object can be set into motion. Then the next type of the friction is sliding friction. As you all have enjoyed this sledging and sliding in your childhood, as well as nowadays also. Whenever you get a chance, you definitely you would love to slide. Then sliding friction is the friction acting between two bodies when they slide on one another with the uniform speed. This, you know about the action, you know how the sliding occurs. So this, when two bodies are sliding upon each other at the uniform speed, this is called sliding friction. Let us see this penguin, what this is doing. It is sliding on the snow. When an object starts sliding, what happens actually? The contact points on the surface do not get enough time to locking into the contact points of the floor. As we have discussed earlier, that the points, like friction depends upon the irregularities of the surfaces also. What happens when the objects slide upon each other? These interlocking, the objects, they do not get enough time to interlock into these surfaces and they just slide. As this penguin is sliding here. So we can say when an object starts sliding, the contact points on the surface do not get enough time to locking into contact points of the floor, and then the object starts sliding upon surface. When an object starts sliding, the contact points on the surface do not get enough time to locking into contact points of the floor, as we have discussed earlier. So sliding friction is slightly smaller than static friction, because whenever the things are sliding, the contact points on the surface do not get enough time to lock into the contact points of the floor. So here we can say, we can conclude sliding friction is slightly smaller than static friction. Let us have this, let us watch this video of a rolling ball, friction of a rolling ball. You can see here that the ball is rolling on the smooth surface, and after some time it will come to rest. It will take some time. Here it is the smooth surface, it is a floor on which the ball is rolling. Then after some time it comes to a halt. Then you can see here the ball is rolling on the road and it is a bit inclined. It is a bit inclined, and look at the speed of the ball. It is rolling faster. If it is like, and here we have a flat rough surface where the ball is rolling. It is a grassland. It is a plot of grass where after some time this ball stops. You can watch here. This video I've shown to you just to understand the rolling of a ball. So what is this rolling friction? The force of friction that exists between two surfaces when one body rolls over the other body. Here you can see this, the example, very good example is wheel. The force of friction that exists between two surfaces when one body rolls over other body. This is called rolling friction. Rolling actually reduces friction. You can see here the boy is picking up this, rolling this suitcase, and this is a gif of a roller skating, a person doing roller skating. Rolling actually reduces friction. That is why it is easy to move a heavy object when it is lifted with wheels, when it is fitted with wheels. If this object is not fitted with the wheels, then you need more force to move this. So basically, rolling reduces friction. Here we can conclude from these examples that rolling reduces friction. Another example is there that you sprinkle water on, you sprinkle powder on carom board when you play. Why this is so? Why do you sprinkle powder? Because when we sprinkle powder on carom board, the surface of the carom board becomes smoother. And this reduces the friction between the surface of the carom board and the striker and the coins. As a result, the coins and the striker can move easily on the carom board. This you all have experienced at your places whenever you play carom board game. So now we have concluded that rolling friction is less than sliding friction, and sliding friction is lesser than static friction. Static friction is more, sliding is lesser, and rolling is the least one. So let us understand this with this activity here. I would like to show you the activity.
To begin the activity, place the box on the table and tie a string around it. Attach the hook of the spring balance to the string. Pull the box with the help of the spring balance.
Here you are pulling the box with the help of spring balance. You are actually sliding the box on the table.
The box is sliding. Note the force indicated by the spring balance.
Now see, the reading shows 800.
Now place the pencils parallel to one another on the table. Carefully place the box on the pencil. Pull the box with the help of the spring balance. It is now easier to move the box. Is there any change in the force required?
Now you can look at the reading. It shows 400.
Reading on the spring balance. It shows less force.
So here we can conclude again that rolling friction is lesser than sliding friction, as we have seen in this activity. Okay, so in the next video, we will be discussing fluid friction. We will be meeting again in the next video, and till then, have a nice day. Bye-bye.